Hello there, FS 201 students. Welcome to our lecture continuation. We had an interview on Monday with Kristen Sangia, and I hope you enjoyed that and got a new window into some career options, particularly in regards to food safety for food science. We'll start today with announcements. So Quizam 9 is due today, Wednesday, March 25th by 11:59 p.m. if you're watching this on March 25th. Packback question and responses are due Friday, March 27th by 11:59 p.m. And Quizam 10 opens Friday, March 27th. That's this Friday, and is due next Wednesday, April the 1st. So if you have any questions or concerns or things come up, you don't have access to something, you're having technical difficulties because everyone in the world is seeming to get online, or in the United States at least, to do their job or continue their education, let me know. So the easiest way to do that is to email me directly. So reach out to me or post on the Q&A forum for our Moodle page. So both those ways, I will try to keep up to date with everything. Be patient with me because we are moving online for everything. And so there's lots of questions and issues that come up that I'll be addressing. But I promise you I will get back as quickly as possible. All right. So I wanted to start out with a packback question. And as I've mentioned before, this is your opportunity now to ask questions since we're completely asynchronous as far as lecture goes. So one of the questions that came up, and obviously what's on everyone's mind, is coronavirus. And so this question came up on Packback about COVID-19 and what can food scientists do to help. So I wanted to really address this issue with regards to food and food supply and coronavirus and COVID-19. So a couple of resources for you to look at, some articles that I found, as well as things from the FDA. The FDA is the Food Drug Administration. When we get more into food law, which we will shortly, you'll find out more about them. But they're the ones that regulate a lot of the food that is in the United States. The USDA does meats and eggs, things of that nature, but the FDA regulates the majority of our food supply that is not animal-based. So the FDA is doing a couple of things. You may have noticed, or your parents may have noticed, or someone you know that is doing the majority of the food procurement for your family or where you're living. You go to the grocery stores and the shelves are just much more empty than normal, especially things like fresh meats are less in supply in the grocery store in particular. And really what that's stemming from is not a shortage of food. It's a difference, an imbalance between the supply and the demand. So there's been a big spike in supply as everybody has gone into a bit of a panic, thinking that they're going to be confined to their homes for a month or more in response to the pandemic of coronavirus. So that spike in demand, people bought a whole lot more than they normally would, and then the supply chain just hasn't caught up with it. So the FDA has put out statements that in regards that we are not in a food shortage. There's no evidence of a food shortage, so don't be worrying about that particular thing. The problem is that people keep panic buying, and the supply chain just can't quite catch up because it was steadily at one demand level, and we have ramped up the demand trend tremendously. I think that will balance itself out as we get further and further away from the initial shock of this social distancing that's being implemented. The FDA is also doing its part to help the food supply maintain strength and supply. So the FDA is streamlining food inspections. They are making sure that some of the new laws that have been put in place with FSMA, the Food Safety Modernization Act, which we'll talk about, that those laws that are still sort of new and are more difficult and not quite as rote for a lot of food suppliers, that those inspections are being streamlined. And as far as inspection of other countries and suppliers that are from other countries, so those inspections as well are being streamlined in order to help maintain that food supply. and make sure that we don't have a food shortage. So there's a couple of different things going on here with our food supply. And then the final piece to this is, how is coronavirus itself impacting our food? And the good news is that we are right in the middle of learning about food safety here in FS201. The good news is that coronavirus is not foodborne. You are not going to contract this virus by consuming it into your body. The primary mode of getting it is with respiratory particles from other people that are infected. So it would be very unusual for you to consume a food that has the virus on it and get the virus, get COVID-19 from that food. What we do need to be concerned about is that the employees that are producing this food, and we need them to keep producing it throughout this pandemic, that, excuse me, those employees are safe from the coronavirus, and that we are maintaining the proper protocols for making sure that our manufacturers and distributors are sanitizing things and keeping workers that are known to be ill out of, or have tested positive, out of the processing plants and the distribution facilities. So you can check out those types of requirements here. I did want to share this particular document. You can find it here at this link. If you go there, this is in regards to COVID-19 and food safety. So this was put out by some NC State folks in Extension, and it's basically telling you that the food is safe. There have been no documented cases that people have gotten COVID-19, which is the actual illness. Coronavirus is what causes it. COVID-19 is the illness. No one has gotten COVID-19 or has been traced to have gotten COVID-19 from food or food packaging. So this is a very minimal risk that you would contract this illness, this virus, from this pathway. So it tells you a little bit about safe handling practices. And this would apply to any food that you're getting or any other supplies that you're bringing into your house from a store. So take a look at this, read through it, share it with others so that they can feel safe about their food supply as well. All right, so now we're going to get back into foodborne illness. So if you'll remember from 2 weeks back, we looked at the particular different types of illnesses and the impact that has, foodborne illnesses, the impact that has on the U.S. population. So the CDC is estimating that each year, 1 out of 6 Americans is going to get sick from foodborne illness. So that's about 48 million people. These numbers take on whole new meanings in the middle of this coronavirus pandemic, and we're constantly looking at numbers like this of who's getting sick, how many have been hospitalized, how many are dying. So these numbers all pertain to foodborne illnesses. 128,000 are then hospitalized. So if 48 million get sick, then 128,000 are hospitalized with that foodborne illness, and then 3,000 die. So this is a problem. This is a problem that we're continually working on as a society. The FDA focuses on how to improve the outcomes for foodborne illness, as well as decrease the risk of contracting foodborne illness. Remember that there are 3 different types of foodborne illnesses. There's the infection, where the bacteria is ingested and it grows within us, and that damages tissues. Intoxication, on the other hand, is some bacteria or other microorganism is growing on the food and it produces a toxin. That toxin is then ingested, and that toxin is what's causing the illness. And toxico-infection, where bacteria are ingested, they grow inside our GI tract, and they produce a toxin in the gut, and that toxin is what makes us ill. But that toxin is produced within us. We aren't consuming it initially. So 3 different modes of illness that can happen here with foodborne illnesses. So if we're talking about foods, what foods are most likely to make you sick? Particularly from microorganisms. We're not talking about stomach upsets or things that don't disagree with you. We're talking about getting sick from microorganisms. So what foods are most likely to make you sick? Let's think about that a little bit as we move forward. So you can imagine that raw foods are oftentimes what makes you sick, meaning that raw fruits and vegetables that don't get heat treated, right? We've learned that heat processing reduces the microorganism load, and in most cases, we're looking for it to kill any pathogenic material that's there, organisms that might make us sick. So raw foods, whether that is raw meat or fresh produce, oftentimes will be what we think of as getting ill from. So we're going to go through three different case studies and look at our three different modes of illness here. The first one we're talking about is food infection. So this is a documented case of a baby shower that happened, and the baked ziti was prepared and fed to the attendees. So 24 people were there to celebrate this pregnancy and birth. 21 of those people reported severe diarrhea after the fact, fever, vomiting, cramps within 24 hours. So this was pretty quick, one-day turnaround, and you'll notice that that's true of most foodborne illnesses. This is a pretty rapid turnaround for ingestion and signs of symptoms. 18 of these people were hospitalized. So a good portion of the ones that reported any kind of symptoms were hospitalized. That included the 38-week pregnant woman. The baby was born with septicemia. All of these folks tested positive for Salmonella enterica. Okay, so this is a known pathogen. And so all of these folks consumed this baked ziti at this baby shower and then reported illness and were infected. So this is our first food infection. Salmonella is a food infection, meaning that you consume the bacteria grows within your gut, and that's what causes problems. The second case is a case of food intoxication. So this was a case of a dinner party. The menu included whole roasted turkey. So this is a raw product that starts out with and is quite large. So there's a lot of mass in this whole roasted turkey, meaning that it takes a while to get hot enough. It takes a while to cool down, and then it takes a while to heat up again if you're in the whole form. So all of this time delay in getting to the temperature that is safe means that it gives the organism that is there more time to grow. So 52 out of 101 attendees at this dinner party showed symptoms within 7 hours. This was a very rapid turnaround. And in food intoxication, that's normally the case. You're basically eating a poison, a toxin in this case. So the symptoms were vomiting, diarrhea, abdominal cramps. 49 of these people required medical attention. So once they went back and they looked at this, the CDC went back and looked at this, they were able to isolate high amounts of Staphylococcus aureus from the leftover turkey. And this is a bacteria that produces a toxin. So this is an intoxication. The toxin that was consumed from this turkey is what made everybody sick. Further investigations revealed that one of these food handlers actually had a facial rash. So they had erupting acne, essentially, on their face. And that was the source of the Staphylococcus aureus. So Staph aureus is what we call it for shorthand version there. Staph aureus lives all over us. It lives all over our skin. It lives in our mucous membrane nasal passages. So all it takes is for some food handler to pick their nose and then touch the food, give that food time to incubate and grow that Staph aureus and produce the toxin, and you have yourself a foodborne illness, food intoxication situation. So to further compound that, the turkeys were not cooled properly, and they were served at inadequate serving temperatures. So they didn't come down to the correct temperature after cooking, and then they never got reheated to the correct temperature. So there was some definite mishandling of food here that caused 50% of those folks to come down with something that required medical attention. The last one that we'll talk about is toxico-infection. So this one is a much larger case. This is a corporate luncheon, right? So we have 420 people there, 300 of which got sick, and they became ill 9 hours after the event. So abdominal cramps, diarrhea. The disease lasted about 12 hours, so relatively short-lived. Still no fun, right? Still no fun to be sick with this type of infection. And what it was narrowed down to eventually was Clostridium perfringens. This is a toxico-infection. So what happens is the organism proliferates on the food source, which was a roast, and then you consume that organism. The organism grows within your GI tract and produces this toxin. So these roast beef were cooked 3 days in advance. The sanitation in the cooking facility was poor. So proper sanitation was not followed, probably had some cross-contamination from raw product to cooked product. And then to further compound it, the refrigerator was not at the proper temperature. So these things didn't even get cooled down to the right temperature, leading to the perfect environment for the Clostridium perfringens to grow. So roasting did not kill the spores that were on this. We talked about Clostridium botulinum with respect to canning, and that spores are really just dormant cells waiting to grow. And they're sort of in this hibernation, highly protected hibernation state. So in this case, the roasting did not kill these Clostridium perfringens spores. And not every bacteria has spores, only some form them. So Clostridium perfringens is one of those pathogenic organisms that does form spores. So if we had roasted it longer, perhaps we would have had adequate time to kill the spores. And then the fact that sanitation was poor and refrigeration temperatures were not correct further compounded the issue. The roast had 3 days to sit and wait in an environment that contributed to the Clostridium perfringens growth. Right? So those are 3 different cases of different modes of illnesses, right? Different ways we can get sick from pathogenic organisms in food. And in almost all cases, these were animal products that were causing the illness. So let's look at what kinds of foods make us sick. Can any food make us sick? Is there more likelihood from one type of food to another type of food? So if you look at this graph, and this was 2009 to 2016, and this is from the CDC. So these are reported cases, keep in mind. Fish make up a good portion of this. So this is raw fish as a product, 17%. Are there. And if we look around, what's making up a lot of this is animal-based products. So fish, dairy, chicken, beef, mollusk, pork. All of these, over 50% of this wheel, are cases of foodborne illness from animal products. If we look into it further, vegetable or row crops is here, fruits. These are both raw products that typically don't get, or that can be eaten raw and don't get some kind of heat treatment to kill off bacteria. So those are another big contributor, which could be anything. And then we start getting smaller and smaller percentages. Things like turkey that aren't consumed quite at the same rate as fish and dairy also has a smaller amount of illness from it. Right, so we can look around this wheel and see that what we have to risk. Now, that's where those foodborne illnesses are coming from. So let's see about illnesses that require hospitalization and then deaths. How does that play out with different food products? And you see here that produce by far has the highest amount of illness that's caused by it, while meat and poultry is much lower, about half the amount, less or more than half the amount for illness. The difference here is that if you do get a foodborne illness from produce, deaths are about 23% of these cases. When we get an illness from meat and poultry, 29% of those cases result in death. So we do see a slight increase, meaning that the hazard of dying, the mortality rate here is higher when we start thinking about organisms that we might contract from meat and poultry. And then dairy and eggs, it starts to go down just slightly as far as illnesses and deaths. And then fish and shellfish down here at the bottom, they're about equal on either side of illnesses and deaths. All right, so we've got some varying lethalities, if you want to think about it that way, with these different organisms. So should we expect the federal government and the food industry to make our food 100% safe? This is something I often hear from students is we need to do more. We need to do a better job of making our food supply safe. But if you haven't learned anything in this class, I know that you've learned that our food comes from dirt, right? We have to have dirt in order to have food, no matter what level we're talking. So organisms are very prevalent in that environment, and so it's impossible to make our food supply 100% safe. We can do a lot to mitigate risk, and we do have laws on the book that go a long way to help reduce foodborne illness in the instances they're in. And that's our next section that we're going to talk about, food laws and how those help. But the amount of manpower and dollar amount to be that would have to be invested to make our food supply 100% safe would just not be worth the reward. It would take away all profit from that system. So that's not going to happen. Microorganisms are everywhere. And the key to this is how do we minimize foodborne illness rather than eliminate it? So when you're in your kitchen thinking about how to minimize foodborne illness, this is what the CDC recommends. And this is just proper sanitation when you're dealing with food, whether you're preparing it for yourself or whether you're preparing it for 100, 300, 400 people. Okay, so basically, cleanliness is highly important. And now you've heard this 100,000 times. Wash your hands, wash your hands, wash your hands, wash your hands. And not just a little rinse under water, not just to rub around with soap, but really wash your hands, making sure that you're getting your nails clean underneath, that you're getting in between the fingers really well, around the edges of your wrist. All of those things are really important to make sure that your hands are completely sanitary. You need to clean food contact surfaces. Clean fresh fruits and veggies. Rinse those off really well. This will help prevent any organisms from coming into the kitchen. Another key point here is to keep raw foods separated from cooked foods. This way we prevent cross-contamination of bacteria from a raw food or microorganism from a raw food coming in contact with something that is that has been heated, right? So keep raw meats separate from other foods, especially ready-to-eat foods that are ready to go. And we need to make sure we are watching temperature when it comes to food. We all know that cooking our food makes it a safer product to consume if it's cooked to the correct temperature. So for whole cuts of meat, that's around 145 degrees Fahrenheit. This is recommendations by the CDC and the USDA. United States Department of Agriculture, and the CDC deals with disease, Center for Disease Control. For ground meats, 165 degrees Fahrenheit. And for leftovers or casseroles where there's been lots of things mixed together, 165 degrees Fahrenheit. The reason whole cuts of meat are lower than these ground meats and casseroles is because most of the contamination for meat, all of the contamination for meat is going to be on the exterior surface of the meat, right? As far as bacteria go. There are some parasites that can be in meat, but typically they're killed by these temperatures that are recommended. So if it's just bacteria on the outside that we need to be mostly concerned about, we can cook it to a lower internal temperature, right? Because these are all internal temperatures. The coldest spot, this is where it needs to be at minimum. Okay, so for ground meats like hamburgers, it's important to cook to 165 degrees Fahrenheit. And same thing for leftovers and casseroles. Once you've achieved that temperature, you need to make sure that you're cooling your food quickly. So refrigeration temperature should be about 40 degrees Fahrenheit. So make sure that you are getting it into a refrigerator or cooling it down very quickly. This is even more important when we start to consider larger cuts of meat like a turkey or a big pot of soup. How are we going to increase the cooling rate so that gets down to that cold temperature and stays out of that danger zone where bacteria like to grow. We want to get down to that cold temperature faster. It's also important when we start thinking about thawing larger cuts of meat. What you need to do is put it in the refrigerator and let it thaw at that cold temperature where bacterial growth is very low until it is thawed. Thawing it on the counter is a bad idea. It puts the exterior of that meat at that perfect growth temperature for a longer period of time. And then finally, when you're done consuming the food that has been cooked, refrigerate it quickly within 2 hours to make sure that we keep it at a safe temperature. So let's go back to those case studies. We know what caused the illness. How could we have prevented it? So the baby shower that had 24 attendees, 21 of which were diagnosed with salmonella. How could we have prevented it? It turns out that an egg used in this casserole was the source of the salmonella. So what we needed to be sure to do is we need to heat this to 165 degrees Fahrenheit, that coldest point, the center point of the casserole. So if the casserole had been heated to 165 at that coldest point, we wouldn't have had a problem. Those proteins in the bacteria Salmonella would have been denatured and the cell would have died. Unfortunately, many of those attendees recalled that the center of the casserole was cold, and so clearly this did not happen, which resulted in food infection. Our food intoxication, where we had the whole roast turkeys and Staph aureus was the problem. How could we have prevented this? So proper sanitation, hand washing, not touching your face. This may sound familiar. So proper sanitation of hand washing could have been more enforced, having a refrigerator at the appropriate temperature, 40 degrees C, and then furthermore, if it's cooked in advance, it needs to be reheated to that 165 degrees Fahrenheit coldest point, right? So none of these things were followed. Even though this is a toxin, the proper sanitation of hand washing and not touching your face could have prevented contamination in the first place if that had been followed. And then further, keeping the temperatures in the right place would have prevented the organism from growing. So making sure that refrigeration at 40 degrees C is what happens, and then they are cooled very quickly. So maybe slicing them before putting it in the refrigerator overnight and ready for the next day. You need to make sure it's heated up to the right temperature. So all of these things would have helped to prevent that Staph aureus from getting on the food and then from further growing. The food toxico infection, this was the roast beef with Clostridium perfringens, spore growth under improper conditions, and so storage conditions particularly. So again, temperature management is key. Hand washing is key. So refrigerators that are at 40 degrees Fahrenheit, making sure things are cooled appropriately and then reheated to 165 degrees Fahrenheit, and proper hand washing. We probably could have prevented contamination to begin with if proper sanitation had been part of this equation, right? So you see those core rules that the CDC recommends for food preparation and how to do that in a sanitary manner could have prevented all three of these outbreaks from happening and all of this illness from happening. Just need to follow those rules. These are the key rules, right? So how do foods become contaminated before they even reach your kitchen, right? So what we just talked about, those 3 case studies, were really from a consumer standpoint, once the consumer gets the food and how they handle it. But we know from food recalls and things that food can be contaminated prior to even reaching us, right? So when does this happen? How does that happen? So when the system of harvest to consumer breaks down, that's when contamination can happen. And there's many factors that affect the growth of microorganisms. And we've learned about a few of these so far. Acidic foods, typically we're less concerned about microorganism growth when we have an acidic food. So pH, low pH, like in the case of anything that is pickled, pickles, cucumbers, pickled beets, sauerkraut, anything like that, we're less concerned about microorganism growth. If we have a low water activity, remember if we're below 0.8, 0.6 to be very, very conservative water activity, we're not going to have microorganisms growth. There's just not enough water there for that to happen. And then maintaining processing temperature and time. So if you remember back to making ice cream in particular, some of our very first lectures, that processing temperature and time is monitored by the FDA. So those records are kept. It's that important. With the proper temperature and time, we can make sure that organisms or pathogenic organisms are eliminated. Packaging integrity. If we can keep organisms from the environment from recontaminating the food, that's important. So if you've seen a box that's torn or plastic that's punctured, it's generally advised not to consume that food. And then further, if we can prevent cross-contamination from happening, and we'll talk about a few cases of cross-contamination here in just a second. So all of these factors really make a huge impact on how are these microorganisms growing and what foods they're growing in on the distribution side. So we have the food production chain, right? Down here we are, our home cooks and consumers or food service, restaurants and that type of thing. But before the food even comes to these two locations, we have to have production on the farm, processing of those products, and distribution. Now you may think of something like, say, an apple. We have the production on the farm, it's harvested, and even those apples are processed. They go through a washing process, some type of packaging typically. Even at the grocery store, if you just see it laid out in a large pile, those apples came in a box of some sort. So this processing goes on here with any food you come in contact with, and then distribution, whether how it's transported to the facility where it is sold, like the supermarket or the restaurant. So all of these places are opportunities to prevent contamination and prevent foodborne illness. So let's think a little bit of some cases that we have had in the past and what we have done to prevent them in the future. All right, so this peanut butter outbreak was a huge outbreak at the time. It was a very big story. And strangely enough, in 2008 to 2009, salmonella was the culprit in peanut butter. Now, where do you store your peanut butter? Think about that for a minute. You go to the grocery store, where is it sold? It's on the shelf. It's not refrigerated. When you bring it home and you open it, we put it back on the shelf. We don't refrigerate it. There's no recommendation on there that you need to refrigerate it, right? This is a food that has a very low water activity. And so we aren't concerned about bacterial growth typically. All right, so what do the numbers look like in this outbreak? There were 714 people who were infected. This is across 46 states, okay? So this is where distribution starts to play into increased numbers when people do get sick. Half of these people were children, all right? So this does have a big effect. Salmonella can have a big effect on children, and 9 deaths resulted from this outbreak. Typically, we see salmonella associated with poultry products like chicken, eggs, turkey, all of those particular products. So how in the world do we get salmonella contaminating our peanut butter? All right, so how did this happen? So there's a large food plant, right? So we're processing our peanut butter, roasting the peanuts. The peanuts come in raw, we're roasting the peanuts. The peanuts are then ground and packaged into a container. This plant did have some issues with sanitation. There was standing water on the facility floor that didn't get cleaned up regularly. And the big problem here was a roof leak. So on top of the roof of this peanut butter plant were birds. And birds were doing what birds do, living and pooping and doing what birds do. And so when it rained and the roof was leaking, all of the contamination was from those birds on the roof. right? So the water that was on the roof that was contaminated with the salmonella from the wild birds that were up there was leaking into the pilot or to the plant. Now you may say, why is that a problem? The problem is that between roasting and packaging, there is not another heat step that would inactivate those organisms. So we take roasted peanuts, grind them up. So now we're taking any contamination and blending it in with everything else and package it. And even though this is a low water activity food and the salmonella could not grow in that food, which is up to this point what we were really focused on as an industry, even though the salmonella could not grow in that particular food, it could hibernate there quite well. So what happened was that the salmonella survived in the peanut butter even at that low water activity. And then once it got into the host, the person, it grew and caused foodborne illness. So that was the problem. The reason that it was an even bigger problem was that these companies knowingly let product go out the door that was contaminated. So this involved 361 companies, almost 4,000 products. This was the biggest recall ever in U.S. history. And think about tracing all those products from this original ingredient supplier. So this company did not make products necessarily, but they supplied peanut butter to go in all kinds of other products. Think the little nab crackers where you have 2 crackers with peanut butter in between them. The Ritz crackers that have peanut butter in between them. Reese's Pieces, Reese's Cups. There's all kinds of candy that has peanut butter in it. So all of this peanut butter was shipped to go in to other products as an ingredient. And so now we think about tracking all of that different product that goes to all of those different manufacturers and then goes up to all the different stores and all the different homes. This is a lot of logistics. All right, so the Peanut Corporation of America was the company that this problem originated with. They knowingly shipped products with salmonella, and this resulted in some legal action. So the owners were convicted of conspiracy and fraud and got 28 years in prison. So this is not something that the federal government takes lightly. The knowledge and complicity in this event. The quality assurance manager was sentenced to 5 years of prison. And if I'm remembering correctly, I believe the quality assurance manager alerted the owners to the problem. So he knew about the problem, but the owners said ship anyway. Right, so that's salmonella. That was our one of our most recent huge outbreaks that really caused folks to reevaluate how we are handling foodborne illness at the production level. More recently, we have had numerous outbreaks of romaine. So the initial one associated with romaine, the initial one was in 2018. The outbreak in particular was E. coli 0157H7. This is a bacteria that lives in our environment, but this E. coli in general, but 0157H7 is a pathogenic strain of that particular organism. This affected 16 different states. It had 62 illnesses. So notice that these numbers are much lower than our case with salmonella. This is partly due to new laws that have been put in place between these two events. 25 of these cases were hospitalized with hemolytic uremic syndrome. And the sad thing about this is that oftentimes when you get what is abbreviated as HUS, this has to do with your kidneys, this is permanent damage. Okay, so this is not a once and done kind of event for folks that do contract E. coli 0157H7. Oftentimes there are the remainder of life issues that are dealing with kidneys, but no one died in this instance. So that is positive in this case. A public health advisory was issued on November 20th, and then the FDA requested that the industry withdraw product from the market and withhold distribution. So this at this point in the initial outbreak, they had no idea which particular romaine lettuce was contaminated. They didn't know what farm it was coming from. And so every farmer that was producing romaine had to pull their product and withhold distribution. So this affected numerous growers. This had a big impact economically on romaine growers. So where is E. coli found? E. coli is found in the environment, but E. coli 0157H7 is oftentimes associated with the intestinal tract of cattle. We had a very large outbreak that really sort of kicked off modern food safety practices in, I believe it was 1997 at Jack in the Box fast food chain. It was associated with hamburgers and E. coli 0157H7. So this organism, this pathogenic organism, is found in the intestinal tracts of cattle and is shed with fecal matter. So how did that organism then move into lettuce, fresh leaf lettuce, right? So that progression happened because of water runoff. Very close to this romaine farm that they eventually isolated the contaminated product from, very close to that farm was a livestock area, right? So what happened was that the runoff from the livestock area was contaminated with E. coli 0157H7 from that livestock and ran off down to the romaine field and got on the romaine. Normally, if we were cooking a product to the proper temperatures, this wouldn't be a problem. Romaine is one of those products that's very rarely, if ever, cooked. And so it is eaten raw, ready to eat, right when you buy it from the grocery store. And that's where a lot of the problem came in. Now, we have seen this outbreak again in 2019, right? So it happened initially in 2018. 2019, we saw the same type of outbreak again, right around Thanksgiving. So we were able to contain that a little bit better. Our radar was picking up that type of thing much more readily. So there is some theory out there. They need to obviously study this more, and that's going on. There is some theory out there that some beef cattle become super shedders of this organism right around that fall time. And so the likelihood of contamination goes up because we're seeing it repeat itself, same time of year, same products again, right? So California, where this has originally happened and happened the second time around in 2019, has tried to institute some water testing protocols for their farmers to make sure that we prevent contaminated water from getting on these lettuces, right? So there's all kinds of repercussions from outbreaks, and the more we learn, the better off we are at preventing this from happening in the first place and decreasing the risk. Something that I hear from people quite a bit is that now it seems like there's food recalls all the time, more than ever. And I do have a Google alert email that comes in every week with food recalls, and there are a lot of food recalls. And this is the result of a couple of different factors. So food recalls don't linearly correlate with food safety. Okay, so if there's more recalls, there's a decrease in food safety. That's not the case. There's several different factors that go into why that food recall number is higher. So now in our society, we have moved from farm to fork. We've moved it out to global farm to fork, right? We have strawberries all year long. You can get them all year. In November, December, they don't grow in North Carolina at that time of year typically. There are some different agricultural practices that you can get them to grow, but not typically, right? So this global economy is really impacting how much we see recalls being put into place, because if an ingredient that was manufactured, say in Brazil, and is brought in and put into products in the US, now we have much greater distribution, right? So that impact is magnified not only by that global nature of our food system, but also because food manufacturers are becoming much fewer and much larger. So whenever we have a larger food manufacturer, if there is a recall, it seems to be on a much bigger scale, especially with this ingredient to producer type pipeline. And the last part is really a huge portion of this equation. We have made incredible strides in our testing methods and sensitivity and microbiological identification. So we can take a sample that has very low amounts of organisms, grow those organisms up quickly, and identify their DNA or RNA from them very, very rapidly. And this helps us really get a fingerprint, a genetic fingerprint on a particular organism, particular strain of this organism, much easier and much more reliably. So we can sequence the whole genome very, very quickly. This helps us identify things and then track these foodborne illnesses much easier and reliably. So what does that mean when we start talking about recalls? If we can track these things or we can detect these things at very low numbers, what does that mean about the traceability? And this is a huge discussion that's going on right now in the food industry. How easy is it to tell where your food is coming from, where all the ingredients that are in that product is coming from, and how it's moving through the processing and distribution chains? So we can track illnesses with CDC's PulseNet. This links illnesses to one another so that we can sort of get a map of the general illnesses that are there and sort of track things down that way. But it's still really time consuming to track illnesses down to a particular field or a processing facility or a grocery store. So one of the areas that is a big area of research right now is blockchain technology. You may have heard of this, but it's a way to very quickly trace a product and its ingredients through production, distribution, and purchase. This is still something that is quite large. Companies are hesitant to put it in place because there's still a lot of questions about it, things that need to be figured out. But it is coming. We need to be able to track things extremely quickly and with extreme accuracy in order to reduce the risk of foodborne illness as much as possible. And the last part of this was that we're moving to better and better laws for prevention in food safety. What we had prior to 2011, and that 2011 was when the Food Safety Modernization Act, which I mentioned previously, was enacted. And that was a huge sweeping change for folks in the food industry. That act moved from a very reactionary standpoint of, oh, people are getting sick, I need to recall products, to preventive, right? And so if it seems like, if you hear folks talking about that in the past 20 years, we see so many more recalls, part of it is because of this law. This law is moved towards prevention so that if a food processor thinks that they may have contamination, whether that's bacterial, microorganism contamination, or even something like there's errant plastic or an allergen that is not listed in that product, now we're recalling that product before people get sick, right? So this is a preventive type standpoint versus that reactionary standpoint prior to 2011. All right, so that's all for today. I missed having your questions in class, but I know that we will continue onward with this, with everybody being online. If this stimulated some questions for you, use PackBack. That's your assignment. Go ahead and get those questions written down and put in. If you need clarification on any point, I encourage you to use the Q&A forum on Moodle. Until next time.